for this discussion, or for today's lecture discussion, this is a continuation of your analysis of steel structure that is subjected to lecture. So, the first, as earlier na, binigay ko na yung summary, binigay na natin yung summary nung na-discuss natin before. So, for today's lecture discussion, we are considering both the shear and bending stresses that are present sa ating steel structures. So, before we start, I have here the different formulas that are needed, no, if when considering shear stresses for beams. So we have here, sorry about this. So this is the allowable shear stress for a rolled and fabricated shape is 0.4 Fy. So this is fixed po, unless there is a formula that is stated on the problem. So if walang nakalagay na formula, we will assume that the allowable shear stress is 0.4 Fy. But if there's another equation present sa problem, you would have to use that. Kunyari sa problem nakalagay Fv is equal to 0.5 Fy, then you will use that na. So ito yung general allowable shear stress for your steel beams. And then, as I have introduced last meeting, the allowable bending stress or the general equation for bending stress is Fb is equal to mc over I or m over Sx. So we also have a general equation for shear. So for the general equation for shear, we have this equation Vq over Ib. Again, this is general equation, so it can be applied to different types of structures. Can be applied to steel, to reinforced concrete, to timber, since any type of structural member. Sa RCD nyo kasi, since of course, ang reinforced concrete natin most of the time is made of a in rectangular shape. That's why I think 3V over 2BD ata siya, So derived siya. So dito, ito yung general equation kasi nga for steel structure, general shape niya is I-shape. So we can't just use the typical derived equation. So ito yung general equation. But we have what we call your average shear stress. So this is the general equation for shear stress, FV. And then we have what we call your average shear stress. So for average shear stress, we are using this equation. So this is a lot simpler compared to this equation. So this is just, again, general equation for stress. Stress is equal to force over area, diba? Force over area. So for shear stress, Fv is equal to the shear force V over the area, or the average area, the depth times the thickness of the web. So, madali lang siya ma-memorize. Ano lang siya? Force over area. So, just to be clear, so this is your general equation, and then the general equation, and then average shear stress. So, if the question is what is the average shear stress of the steel structure, ito lang yung gagamitin. So, ito naman, saan natin ito gagamitin? This will be used if you are being asked for the shear stress at a specific point on the section. Kasi since we have an irregular shape, the distribution of shear all throughout the cross-section of the, say, I section, of course, will not be uniform. So, kung mag-pinpoint lang tayo ng portion dun sa I section, gagamitin natin tong general equation, which is PQ over IB. Pero pag average siya, we will use V over dTW. So, ito lang naman, the average area is the depth times the thickness of the web. Then, we also have what we call your shear flow formula. So, the only difference of this formula from your general equation is you are going to remove the V. So, before we start, siguro, I'll give you definition of this. So, the V represents the shear force. Shear force siya, So shear force, Q is the area times the centroid of half of the statical moment of area yung tawag sa Q, no? So area siya nung half from the centroid multiplied by the distance of the centroid from the neutral axis. Then I, of course, the moment of inertia. B is the width of the section. So we will further discuss this later pag may problem na para maintindihan niya. So generally, ito lang naman yung added equation. The average shear stress, G over D to W, and then the general shear equation, BQ over IB, and then the shear flow formula, BQ over I. So, yes. So this is the pattern of shear stress distribution. So as I have mentioned earlier, diba sabi ko, the flow of the shear all along the cross section of your I beam is not uniform. So this image actually represents the amount of shear that is present along the cross section of the I beam. So mapapansin nyo, along the flange section, we have a very small value for your shear, and then the bigger shear stress present is along your depth, along your web section. That's why yung equation natin for average shear stress, diba? Average shear stress is equal to shear over dTW. Kasi yung shear stress natin na very large yung value is within this section lang naman. No? So, kaya sa tinawag na average na neglect na natin yung shear stress sa web area kasi kung i-compare natin yung value niyan, very minimal lang siya. So, kaya yung average shear stress natin is just the area we are considering is just the depth of the total depth of the I section times the thickness of the web. So, in-average lang natin. So, I will introduce here a problem later on wherein we can actually plot this pattern of shear stress distribution just to show you na ganito talaga yung shear stress distribution sa cross-section ng I-beam natin. I have here a summary of the basic formulas for your bending. So, sinamarize ko siya para madali. So, for the average web shear formula, we have V over dTW. Yung general shear stress equation, VQ over IB. And then, shear flow formula, VQ over I. We also have what we call your bolt spacing. So, since your steel connection, your steel structure, if connected to another member, one of the main connection is your bolt. So two types yan. It's either bolt connection or welded connection. So this is also a general equation. The same with VQ over IB for your shear stress. The same with MC over I for your bending. So for the bolt spacing, this is also a general equation, RI over VQ. So this can be applied also for other structural members like your timber structure. Diba? Kasi timbers can be glued together or also bolted together. So this is also applicable for timber. So hindi lang siya derived for the steel, no? So general equation siya. You can use this sa kahit anong structure. Yan. So we have RI over VQ. Gawin natin VQ prime para hindi kayo malito. So R actually represents the force on the bolt. The I is the moment of inertia. V is the shear on the structure. And then Q prime is the statical moment of area of the portion that is connected from to the bolt. So I think I have an example naman later on para mas maintindihan niyo yung etong equation na to. So yung application. So also the radius of gyration. So you already know this. And then the Varignus theorem, and then the moment of inertia for the transfer formula. And then If not given, we will use FB is equal to 0.6 Fy, FV is equal to 0.4 Fy, Fy is 248 megapascal, Fu 400, the modulus of elasticity for steel is 200,000. I think sobra din ang isang zero. 200,000 megapascal. So regarding the FB is equal to 0.6 Fy, we will use this only if uh, we cannot actually classify the structure if it is, say, uh, laterally supported or not. Kasi there are problems no, na presented sa inyo na nakalagay na mismo din sa problem. Use FB is equal to 0.6 Fy. If that is the case, no, you don't need to classify it into laterally supported or supported. You don't need to check if what case it falls to, no. So, if nakastate sa problem, kung anong equation ng allowable bending stress yung gagamitan, say for example, it is stated FB is 0.6 Fy, no, do not bother to do the classification, etc. But if also, no, kailan natin to gagamitin? There are problems din no, na nai-introduce sa inyo wherein, for example, hindi given yung depth, hindi given yung thickness, or what I mean is, the properties is not complete. So, in actual way, no, if you are to classify the problem, you cannot actually do that because you are lacking data. So if that happens, you can use FB is equal to 0.6 Fy. Na, kunyari, kulang yung D, wala yung section, wala yung flange width, the only given is the allowable stresses. Na, so, it happens kasi, no, so there are problems like that. So, if you cannot find a way to classify the steel, you will use FB is equal to 0.6 Fy. Ha? Then yan, shear stress is 0.4 Fy. So, I suggest, no, when you're reviewing, you try to do something like this, no, in your own way, no, lahat ng equation na na-present ko, then try to write down the step-by-step process para mas maintindihan nyo siya. Yan, so I think that's all about it, no, the additional equations, no, from what I have introduced last week. So for your shear and bending, these are the additional equations that we need to consider. So again, if you have questions, again, you may just unmute your microphones or raise your hand. Then first, let's have a simple example. Doon muna tayo sa easy. So first, we have compute the shear capacity of a wide flange section having a flange thickness of 10 millimeters. The flange width of 200 millimeters and web thickness of 20 mm. The distance from the top of the flange is 300 mm. Fy is 300 megapascal. So the question is shear capacity. Very important, no? Kasi I always see students that, for example, shear capacity. So, when answering this, don't know what a shear capacity is. Shear capacity is the shear capacity, the allowable shear that the section can carry. Ano ba yung shear? Shear is a force. Diba? So, shear capacity, what is the shear force that this section can carry? So, kung susulat natin siya, your shear capacity is actually your V. So, nawawala yung V. Ano daw yung shear capacity ng section? So, that's, I'm always telling you, no, na dapat, alam niyo yung ibig sabihin ng mga ini-introduce natin na forces. Kasi, common mistake na students, shear capacity, ang ibibigay nila sa akin is shear stress. So, basic siya, pero very important siya. So, huwag niyo ma-interchange. So, dapat naiintindihan niyo po yung stresses and forces sa ini-introduce natin sa topic. So, ano daw yung force or the shear capacity? So, if we have a flange section, ito, the depth is flange thickness is 10 mm, depth is flange with 200, depth is 300, 200. Web thickness is 20, no? So what is the shear force that this section can carry? So yun lang naman yung question. Ano daw yung V? Now, since we have this values, and then we know the allowable shear stress for a beam is 0.4 Fy, and we know that the shear stress, or the average shear stress is V over dTW. So we can compute for your shear stress and then substitute it here. Substitute the depth, that is 300. Then substitute the thickness of the web, which is 20. So we can actually compute for your V. So direct substitution siya. Now all you need to keep in mind is dapat naiintindihan nyo po yung question. So let's see what's the answer. V over dTW, 0.4 Fy V dTW. So, yeah. So the shear is 720,000 Newton or 720 kilonewton. So just to check, let's add here the unit. So Fy is megapascal, Newton millimeter squared. So we have the shear in terms of Newton, then area mm squared. So check na. So we will have the final answer as Newton divided by 1,000 to convert it into kilonewton. So again, this is a simple example first. So yeah. Next problem is a W24 by 94 beam is subjected to a shear force of 900 kilonewtons. Properties are given. A17, 870, thickness of the web 13, thickness of the flange 22. Yeah, depth is 616, PF 230, X119. Okay, so first, compute the shear stress at the junction of the flange and the web. So what does it mean? So ito yung sinabi ko before, na we can actually solve for the shear stress specifically dun sa cross-section ng I section. So in this case, we are being asked for the shear stress at the junction of the flange and the web. I have here the image of the problem. So yung pino-consider natin is the shear force daw sa junction dito. Sa junction ng flange and then ng web. So ito yung pino-consider natin. Now since we are being asked for a specific point on the cross section, of course we will not use the average shear stress formula. We will use the general equation VQ over IB. So again, we will use this equation. So for the Q or statical moment area, this is how we compute for it. So we will just use half of the cross section. So in this case, the highlighted portion. So we will only consider the highlighted portion. So from the centroid of the member, about the neutral axis, we will consider half of it. And then the equation for your Q is equal to area times the summation of area and then centroid. So yun lang naman, ganun lang kasimple. So if we are to compute for your Q, the area is this area. So that is 230.15 times the depth 22.15. And then centroid. So 297.40. So in this case, no, kung ang tanong is the shear stress of the entire section, we will also consider this. But since the question is only the shear stress at the junction of flange and web, ito lang. So ito lang yung i-consider natin for the statical moment of area. Now, so the area times the centroid with respect along the neutral axis. So we will solve the value of Q. I think I have already solved it here. So if you have your calculator with you, please do check if I have arrived with the correct answer. No? Good. So that's the Q. And the next is, isa-isahin natin, no? So before we can solve for your shear. So we have your Q. Check. For your I, given yung I. Now, how about the shear? I think provided is a problem. So there's a shear force 900 kilonewton. So shear force is also given. Check Q, I is check, V is check. How about the B? Now, again, the B is the width of the portion that we are considering. Now, since ang kino-consider natin is yung portion ng connection ng flange and then ng web, we actually have two B. The first B is the flange width. The second B is the thickness of the web. So we will consider both of them. Check natin. So that's the Q. Solve for the B. So we have 230.15 and then 13.11. And then solve for the value of FB. Direct substitution. Ayun. So 900,000 times the Q times the I times the B. So we will have 5.31 megapascal. Then replace the value of B, 230.15 with 13.11. This will give us 93.90. So we are the shear stress that will prevail is the bigger shear stress now. So that if we design the steel beam, syempre what we need to consider is the bigger stress that it will carry na para mas safe yung structure na i-design natin. So if we are to consider the shear stress at the junction of the flange and web, we'll consider the 93.19 megapascal. No? So yan. So this is how you compute for the first problem, or the shear at the junction of the flange and web. Next is shear stress at the neutral axis. So shear stress at the neutral axis or at the center of the section. So again, specific siya. So we will use VQ over ID. Now in this case, V is again already given, I is already given. For the value of Q naman, instead of just considering this upper portion, we need to consider this entire highlighted portion. So for your Q, copy na lang yung na-compute natin earlier for this one. Then let's add the statical moment of area of this highlighted portion. Yung remaining. So copy yung earlier plus area is, this is 13.11 times 286.35 times the centroid provided 143. Add lang natin, so this will be the Q or the statical moment of area for the shear stress at the neutral axis. So ganun lang yung gagawin. So I think I've mentioned it in this before, no? That's why it is very important that you label your figure properly. No? Kasi kung lalagay nyo na itong mga itong important, diba? So direct substitute na kayo palagi. So dapat, as much as possible, clear yung figure na mas madali yung pag-solve. So there you have it. No? So, inisa-isa ko pa dito. So copy nyo na lang yung kanina. Then, ito nga yung sa web. So for the value of Q, just add, yan, then substitute. Now for the B, what will be the value of B? No? So again, B is the width, no, along the portion na kinukonsider natin. So if we are considering shear stress at the neutral axis, the value of B will be this. So thickness of the web lang naman. Yan. So, yun na. Kompleto na tayo. We have Q and then we have V. So, direct substitution. Yan. So, the shear stress along the neutral axis will be 125.69. Next problem. Sorry. So, what would be the shear force carried by the two flanges? So, anong pwede natin gamitin na equation? So, actually, di ba, again, if you don't know what to do, go back to the general equation that we know. Stress, shear stress is equal to force over area. So, pwede natin siyang i-consider. So, since we already have the shear stress, FV, and then since we are considering area of the flange, so we can check the flange. So, we can get the value of your F. So, ganun lang sa kadali. So, rewriting this will be equal to force is equal to FV times area. So, since we have two flanges, so allowable shear stress is equal to 2 area of the flange. Then, since we have an equal area for the two flanges, no, so times 2 na lang din natin. Yun, so, makakancel lang din siya. So, to get your F, which is equal to the shear stress times the area. Now, in this case, again, for the flanges, so we have two values for your shear. We have the smaller value and then the bigger value of stress. Now, alin yung gagamitin, the smaller or the bigger value? So, isip kayo ng sagot, smaller or bigger? Okay, so, yeah. So, the shear stress that we will be using actually is the, diba ganito siya, FV times A. So, the shear stress that we will use actually is the smaller one. Why is that? Bakit yung smaller yung gagamitin? Forgot. Yung smaller yung gagamitin natin times the area. That is because if we have a smaller value of shear stress, of course, it will result to a smaller value of F. Diba? Smaller value of F. Now, why do we want a smaller value of F? Because at this portion of the section, no, the allowable shear stress there is the smaller value, which is 5.31. So, the allowable force that it can carry is just these 27,069. Now, so sa portion na to, the force that it can carry is only the 27,000. So, if we consider the other shear force, which is the ano ba siya? Which is the 93.19, of course, it will give us a bigger value. Eh, yung bigger value na yon, this portion can carry that, but this portion cannot withstand that force. So, mag-feel siya. So, since we want our structure to be safe, no? So, ito yung gagamitin natin, the smaller value of F. Because this is the limit of this portion. So, sa portion na to, ito lang yung force na kaya niyang mag-carry na. Dun sa portion na to. So, the force being carried by the two flanges will be 27,069 Newton or 27.07 kilonewton. No, so, ito yung sagot. Next naman, what would be the shear force carried by the web? So, since we already have the 27,069 as the force being carried by these two flanges, you don't need to use FV is equal to force over area again. No, kasi we already know the force being carried, no? di ba, ang shear force niya is 900,000 Newton, yung given sa problem. So, 900,000, subtract na lang natin yung force na kinikarry ng two flanges. So, that will result to the force that is being carried by the web. So, subtract nyo na lang siya. So, the force being carried by the web is 872.93 kilonewton. Now, if you'll notice, no, napakalaki ng difference ng force na kinikarry ng web and then the flanges. Now, that's why, yung pwede niyang ma-justify yung figure natin earlier, no? Na yung web portion ng I section is where mas malaki yung shear stress. And then, lastly, we have what is the average shear stress on the web? Again, this is the V over dPW. So, direct substitution. You will have 0.27 megapascal. Okay, so we can actually plot this, no? So we can prove the shear stress distribution pattern. So this is how it will look like. So this is the 5.31, no, and then the 93.19, no, at the junction of the web and the flange. And then at about the neutral axis, we have the largest value of stress, which is 125.69. Pero kung average shear stress lang, that is just 111.27. So, ibig sabihin, if you are asked what is the maximum shear stress of the W section, all you need to do is compute for the shear stress along the neutral axis. No? So, kapag tanong what is the maximum shear stress, use BQ over ID, wherein you're considering the neutral axis of the section. No, so yan, difference ng average and then the maximum. Yan, so if you, as you can see, no, ganito talaga yung shear flow distribution natin for your sorry, W section. Yan. So pinakita ko lang na yung shear stress distribution. So let's have another problem. So, a wide flange and a channel has the following properties. Wide flange area. So, ito yung property ng wide flange. And then, for the channel. So, in this case, no, as you can see, the allowable bending stress are already given. So, therefore, you don't need to classify it if it is laterally supported or not. No? If it is case 1, case 2, case 3, kung compact or non-compact. Kasi provided na sa problem yung allowable bending stress. So, ito yung sinasabi ko. Because there's a lot of times na provided na yung ganitong equation, but you still solve or classify them. No? So, of course, you will arrive with a different value for bending stress. So, mamamali na kayo sa answer. So, when you're looking at the problem, please take note of the given properly, no? So, pag may given na po, yun yung gagamitin natin always. Kasi pre-provide na nga siya sa problem. So, yun, the allowable bending stresses for both your channel and then the W section is already given. So, ito yung W section, no? And then, it is combined with a C channel. No? They are bolted together. Yes. So, first, find the moment of inertia. Next, determine the moment capacity of the section. Third, determine the safe uniform load that the beam could carry over a 9-meter simple span. And then determine the radius of variation of the built-up section in the axis parallel to the plane of the web of the flange. And then determine the spacing of the bolts. Okay. So as you can see kasi dito, so I've mentioned na this before, no, sa discussion natin for your build-up section for your columns. So first thing you need to do is draw the centroid of the two individual sections. So, ito na yun, no? So, ito yung centroid ng W section. Ayan siya. And this is the centroid of the C channel. Bakit nandyan yung centroid? Tingnan nga natin. According to this, the centroid of the channel is located at 20 mm X. So, yung orientation po ng channel natin, no, is ganito. Pinahiga lang siya kasi we place it at the top of the W flange, but the orientation or the original orientation of the channel is like this, di ba? So, meron yung Y and X axis. So, the centroid daw, so obviously this is symmetrical, so we already know that the centroid is here. So, yung Y natin is 0. So, yun. So, yung centroid daw is 20 mm. So, nandito siya. Ulitin natin ang color. So, nandito siya, no? Located at 20 mm. So, this is the centroid of this C channel. No? So, nandito siya at 20 mm. So, that's why when we flip it in a horizontal position, ayun na siya. Ito na yung centroid ng channel at a distance of 20 mm. No? That's why X yung nakalagay kahit Y siya. No? Kasi originally, it is oriented in a portrait way. So, di ba? Ang gagawin natin is locate the centroid of the two individual sections. Then, tulad nung sabi ko before, di ba? You try, you draw the axis. Sabihin na natin na ito yung X, sorry. Ito yung X-axis. Ayan. So, again, if you notice, the centroid of the individual sections are along the y-axis, but they are not along the x-axis. So, we will use the transfer equation. No, ita-transfer natin sila papunta dito. So, for your ix, we will use the transfer equation because we will transfer it to the x-axis. For the iy or the moment of inertia for y, all we need to do is add the iy of the two sections. Na, so ganun, 'di ba? So bago kayo mag-start, ganun yung gagawin niyo, draw the centroid, then check if you need to use the transfer equation or not. Before that, locate the centroid first. So just use the Varignon's theorem. 'Di ba? In Varignon's theorem, just the area times the centroid of the group equal to the individual area times the individual centroid. So, again, what you need to do is look for a reference. So, dito, ang ginawa kong reference is the bottom. Yung reference line natin. So, for the area, or the total area, just add the area of the W section and the I section. So, add nyo lang itong dalawa. Lagay ko na dito. No? So, area 1 plus area 2. And then, the centroid of the group equal to the individual area, area 1. So, times the distance of this centroid with respect to the reference line, so 235, plus area 2, or the area of the channel, times the distance of the centroid with respect to the reference line, 460. Now, so we can solve for the value of your bar y. Yan. So, yung bar y is the, again, no, bar y is from the reference point, no, papunta sa neutral axis. So, ito. So, check natin the answer. Using Varignon's theorem, we can locate the neutral axis or the centroid of the group. Yan. So, we have 293.27 mm. So, let's place it there. Ayan na siya. 293.27. Next step would be, since we already have this, we can now compute for the moment of inertia. So, for your moment of inertia along the x-axis, again, we will use the transfer equation, I plus AD squared. So, sulat ko na. And saka natin i-show yung final answer. So first, moment of inertia for the x is equal to the summation of, since we are transferring both of the centroid from the channel and the W section, so summation of the IN plus AN DN squared. So inahin natin yung sa W section, your IX is 726 times 10 raised to 6 plus the area 18,400 times D squared. Again, D, huwag nyo itong gamitin na nakakita kasi akong D yung ginamit. Again, D is the distance of the original centroid to the new centroid. So, this is your D. So, all you need to do is subtract 293.27 minus 235. So, hindi ko nilalagay yung sagot. Subtract nyo lang yan, di ba? Ito. So, yung D natin, D1. Plus, I plus AD squared of the channel. So, for this is the wide flange. For the channel, we have. Okay, so, ito no, common error. We will use IY in CX. Why is that? Because nga, ito yung original position ng ating section, YX. Since we flip it over, what we are considering really, in this case, is the IY. No, so, may interchange po siya. No, may interchange yung moment of inertia na i-consider natin. Kasi nga, we flip it over. So, sorry. So, yan. Ang gagamitin natin is the IY, the 3.41. Times 10 raised to 6 plus the area 6,430. Then again, the D is the distance of the original centroid to the new centroid or centroid of the group P. This is just equal to 460 minus 293. Nakukuha niyo yung distance. So there you have it. You can solve for the IX. Ganun lang yung gagawin. Use the transfer equation. So, use it for both your wide flange and channel. So there you have it. This is how you compute. Yeah. IY yung ginamit natin dito. So IY 3.41 times 10 raised to 6. Yeah. So we will solve for your IX. Yeah, so IX is 970.62 times 10 raised to 6 millimeters per kilogram. No. Okay, so I did not. Okay, so wala dito na. You need to solve also for your IY since hindi naman specific yung question. So I think I just forgot to write it here. Now, wala naman kasing nakalagay na na balikan natin. Find the moment of inertia. So, since hindi specific yung question, so you need to answer both, solve for both your IX and IY. Sorry about that. So, I think I just missed it here. So, all you need to do is just add lang naman. Ganun lang kadali. So, for your IY, dito ko na IY. For your IY na, for your IY. Now, since they're both along the y-axis na sila, so you don't need to use transfer equation. Add na lang natin yung 93.6 times 10 raised to 6 plus the IX, no? 131 times 10 raised to 6. No? So, ganun lang naman yung sa IY. Add lang natin po. No? So, just write it on your notes, no? Just forgot to add it here. So, lagay nyo na lang sa notes nyo yung IY. Add nyo lang yung IY of the wide flange and the IX of the channel. So, this is how you compute for the moment of inertia. Now, for the moment capacity of the section, yun na, since this is bending, no, we have MC over I. So, direct substitution. We don't have SX kasi, diba? So, if you have your section modulus, use M over SX. But if hindi siya provided, MC over I. So, direct substitution lang naman siya. So, ang gagawin po natin is, since we have two different allowable bending, now you have FB for your channel and then you have FB for your wide flange, we will solve it twice. One for your channel and then one for your wide flange. But the I that we will use now is for the combined or the combined I, not the individual I. So first, for the wide flange, compute for the M. So we have, so one wide flange, no, WF. We have FB equal to MC over I. So we have FB is 118, wide flange 138 equal to M. Now, the C that we will use is this one, 293.27. Kasi ito yung, nandito yung centroid ng group. Over I, yung I na na-compute natin earlier. So, ilagay na lang natin yun dyan. So, we will arrive to the value of your M. Then, for your channel, FB is 118. So, 118 is equal to M. The I is the same. How about the C? So, the C that we will consider actually is this one here. No? From this point, na papunta dito sa, instead of the 293.27, we will use this. No? Kasi nandito yung channel natin, no, sa top part ng neutral axis. So, we will use this as your C. So, this is 480 minus 293.27. This will give us the C. So, siya po yung C for the channel. So, magkaiba yung value ng C. For the wide flange, we will use the 293.27. For the channel, we will use the upper portion of about the neutral axis. Check natin. Yan. So, 138. Again, so correct, no? 293.27. Ayun siya. So, the moment is 456.73 times 10 raised to 6 divided by 10 raised to 6 to convert it into kilonewton meter. Then, for the channel, yan, 480. Tama. 470 plus 10 is 480 minus the 293.27 will give us this height. So that's your C divided by the I of the combined section. Now, what do we choose? The bigger one or the smaller one? We will choose the smaller, correct? Thank you, Mr. Barrett. So, smaller yung gagamitin natin. So, again, the reason for that is, kasi nga, since nagde-design tayo, ano ang ibig sabihin niya? Ibig sabihin, yung wide flange, the capacity or the moment capacity of the wide flange is 456.73. The capacity of the channel is 613.36. So, if we exceeded the 456.73 moment, we will have a deformation dun sa wide flange section. So, ibig sabihin lang nito, mas malakas yung channel. So, if this section is applied with a force, ang unang mag-fail sa kanila is itong channel. No? Itong channel yung unang mag-fail. So, if applied with 456.73, this is the limit. So, kung ito yung gamitin natin, 613.36, safe pa yung channel natin, but your wide flange will definitely deform or fail. No? So, that's why we need to use the smaller value. Kasi we want both of them to this no kasi built section siya, we want it to be safe. So we use the smaller moment. No? So again, that's why it's important that you understand this. No? So sila yung limit, that is the moment that can be carried by these sections. The next one, what is the safe uniform load that the beam can carry? So since uniform load, no, again we have moment. The moment is already solved for 56.73. So a simply supported beam. Now we are assuming that this is a simply supported beam, no? With the uniform load, W. So if you want to get the maximum moment, obviously, no, pag ito-draw natin yung current moment diagram, up, down, the maximum moment is at the midspan. So I already taught you last meeting, no, how, if for example, you forgot how you forgot the equation for the maximum moment, all you need to do is draw the current moment diagram to get the value of moment here or cut it here at the center. So, syempre, this is WL over 2, diba? WL over 2 yung reaction. Tapos, cut nyo sa center kasi alam naman natin na nandiyan yung moment. Get the moment here. Tapos, this is L over 2. So, we will have WL over 2 times WL over 2. So, magiging siyang M is equal to WL squared over 8. Diba? So, again, this is one of the common equations for maximum moment. So, again, just in case you forgot this, dami namang way for you to derive this. Use your moment equation or just cut it at that portion, then solve for the moment. From your structural theory. So, now we know that M is equal to WL squared over 8. Substitute the value of M, 456.73, W. The length of the member is 9 over 8. So, as for the unit, this is sorry. Unit na, this is kilonewton meter. This is meter squared. So, you're asked for the W. So, dividing it, we will be left with W is equal to kilonewton per meter. Kilonewton meter yung final answer. And so, the safe uniform load that this beam could carry, na, so, diba, since this is a cross-section, yan yung 3D niya. So, yung uniform load na i-carry niya should be the 45.11 kilonewton meter. Again, this is a design subject. Nagdi-design tayo ng load na kayang i-carry ng section. So, we consider the allowable moment based on the W section. Tapos, we solve for the safe uniform load. Next, radius of gyration. Very easy. Square root of I over A. Just solve for it. No? So, we have Rx and Ry to consider. Yan. So, for the Iy, tapos Ix. So, we have 95.11. Then, for the Ix, solve natin 197.71p. Okay, so, nagpakita ko na, no? Again, use the least radius of gyration. So, 95.11 yung magpe-prevail. So, again, in this case kasi na, wala naman siyang need support or something. So, we will opt to use the least radius of gyration. So, the final answer is your Ry. Instead of your Rx kasi mas smaller yung value. Now, next naman, we'll go with the spacing of the bolts. So, ito. You're asked for the spacing. So, ano yung tinutukoy niyang spacing? Kasi may connection tayo dyan. Again, this is just the cross-section. So, kung i-drawing ko siya, dito na lang. Sorry. Yan. So, etong bolt, no? Ito siya. Kasi ito yung connection eh. So, may mga bolt siya dyan. So, ano daw yung spacing? Ano yung spacing ng bolts? S. So, I introduced earlier the equation for your spacing, Ri over VQ. So, isa-isahin muna natin siya. So, we have Ri over VQ. V is the shear capacity of the section. Shear capacity na siya ng section. No? So, kung ito yung I-beam natin, ay ito yung beam. Di ba, na-solve na natin earlier yung W. So, again, what is the maximum shear for a simply supported beam? Ano yung maximum shear natin sa simply supported beam? 45.7. Yes po, that is correct. WL over 2 or PL over 2 or the support. No? So, kung hindi nyo memorize yung equation, solve nyo lang yung reaction. No? So, di ba, sa beam, the largest value of your shear is your reaction. So, this is your V. No? So, for example, nakalimutan yung WL over 2 siya. This is just the reaction, di ba? So, 45.11 times 9 divided by 2. So, that is your shear. So, check na natin to. Shear. How about the I? For the I, no, na-solve na natin sa earlier. So, okay na din siya. So, next na lang is your R. Pakita muna natin. So, for the shear, this will be the answer. Shear capacity, WL over 2. So, 202.95 Newton. Now, for the force carried by the bolt, so we have here the shear capacity of the bolt. Now, remember, yung gamit na natin na equation, shear stress is equal to force over area. And in this case, we are considering the FV of the bolt. So, FV of the bolt. So, we are now considering the force carried by the bolt. So, yung R. Now, for the area, diba, if you have this, the area of the shear is the area that is parallel, no? So, that is the area of the bolt itself. So, pi d squared over 4. Area of the bolt siya. So, pi. D, diameter is 16. Pi d squared over 4. Now, we have 2 bolts. Tapos, yung FV ng bolt natin is provided 100 megapascal. So, yun, we can solve for your R. The force or the force capacity of the individual bolt. Yeah, so the force carried by the R is 40.20 kilonewton. Next step, so isa-isahin natin na. So we have your V, we have your R, check. Next will be your Q. So earlier on, na-introduce ko yung Q, yung statical moment of area. But may difference siya, no, for your spacing of bolts. So for the Q here, we are considering the portion lang kung nasan yung connection ng bolt. So in this case kasi, di ba, ito yung bolt na, tapos ito yung portion na kinoconnect niya. So ito lang yung i-consider natin na area. for the Q. Yung portion kung saan natin kinoconnect or may resistance yung bolt. So, yun yung Q. So, most of the time no, I write this as Q prime instead of Q so that hindi siya ma-interchange dun sa general equation for your Q. So, for the spacing of bolts, no, para hindi kayo malito, pwede naman na Q prime yung ilagay niya. So that there's an indication na this is, or the area that you're considering for the spacing is different from the original equation for your capital moment of area. And so in this case, ayun, consider the highlighted area. But again, the same equation, Q is equal to A times Y. So your area is 6,430. Then again, your Y is the distance of the centroid with respect to the neutral axis. So ito yung Y natin. So this is equal to 460 minus 293.7. Na. So yan, makompute natin yung Q. Ayan, so we have, this is 1,072,073.9 mm3. So check, 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 check. So we can solve for your spacing. Direct substitution na tayo. So ayun. So if you want to check the unit, lagyan natin ng unit para sure tayo kung tama. R is in Newton, V is in Newton, I is mm4, Q is mm. So unit, cancel, 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 mm cube. So we will be left with mm. So the spacing now of the bolt for this is 179.35. So all throughout the beam, ito siya. So yung spacing ng bolt connection, ito yung bolt. So yung spacing niya is, ito na yung spacing na kinumpute natin. So ang ginagawa kasi natin is nag-design tayo no, nung built-up section that can carry. No? So ito lang yung kanyang load capacity, 45.11 kilonewton meter, and the spacing of the bolt should be 100, yeah, 179.35 mm. So again, lumiit na lang dyan, wag lang lumaki. So this is the limit. So say in actual, you will not have it 179.35 naman, no? So you want it to be evenly distributed sa 9 meters all throughout. So pwede siyang say maging 160 or maging 150, 170. Basta equally distributed siya all throughout the span of 9 meters. No? Sa actual naman siya. Yan. So, do you have any questions or clarification? You may use the chat box na ito. If wala, we'll go with the next problem. Okay, so go to the next one. We have here a steel beam is made up of a wide flange section whose total depth is 600 mm. Width of the flange is 300 mm and has a flange thickness of 20 mm. Its web thickness is 10 mm and has a simple span of 9 meters. A 40 kilonewton meter uniform load is loaded throughout its span, and a 200 kilonewton load acting at its mid-span. So FB is 0.6 FY. Okay, so here na provided na again yung FB, you don't need to categorize this if it is laterally supported or not because you already have your allowable bending stress. So first, determine the required section modulus without exceeding the allowable bending stress. Next, determine the section modulus of the section. Third, determine the width of the top and bottom reinforcing plate, 12 mm thick if necessary. Lastly, determine the length of the top and bottom reinforcing plate if necessary. Okay, so in this case, no, we have a simply supported beam that is to carry a 40 kilonewton meter uniform load and a 200 kilonewton load at its midspan. So before you start solving na dapat na-visualize nyo muna yung problem. So meron daw tayong simply supported beam. This is the cross section, wide flange. So it's supposed to carry a uniform load of 40 and a concentrated load at the midspan of 200. So ito yung loading ng W section. This is 9 meters. Allowed bending is 0.6 Fy. So, first question is, ano daw yung required section modulus without exceeding the allowable bending stress? Ano yung section modulus ng section? And then, if it is necessary to have a reinforcing plate. Isa-isayin natin. Ano daw yung required section modulus? Recall, ano yung section modulus? That is your S. Diba? That is your S. So, according to the problem, required section modulus without exceeding the allowable bending stress. So, sa question pa lang, alam na natin yung equation na gagamitin. Diba? Kung allowable bending stress, so FB is equal to M over Sx. So, using this equation, we can solve for your Fx. Kasi the FB is given, the loading is also given, so we can compute for your M. Ayan. Solve natin yung M. Ayan. So, correct na, Mr. Bagay. So, yung maximum moment natin is just the, you're just going to add maximum moment for the uniform load and for concentrated load at the midspan. So, for the uniform load, it is WL squared over 8, no? As we have derived earlier. And then, for the concentrated load, this is PL over 4. So, again, just in case you forgot this, all you need to do is draw your shared moment diagram or cut it at the center. Then, use the moment equation. So, solve natin yung moment. So, yan. Kung mapasin nyo, direct substitution lang. So, the moment is 855 kilonewton meter. And then, your FB is 0.6 Fy. So, convert natin to into Newton millimeter, no? So, times 10 raised to 6. Kasi naka-megapascal tayo for your FB. 148.8. Ayan, naging 855 times 10 raised to 6. So, the required section modulus should be equal to 5745,967.74 mm3. Yan. So, ano ibig sabihin niya? Ibig sabihin, no, based on the loading that is applied on the section, yung section modulus, no, should be 5745,967.74. Requirement siya kasi nakabase sa loading na i-apply natin sa section. So, ito yung required. Dapat, yung section modulus ng section natin, no, should not be less than this. No? Kasi ito yung requirement. Magiging, kayang i-carry ng section, yung loadings na pre-provide if ganito yung section modulus. So, answering now, letter B, determine the section modulus of the section. So, itong requirement, no, based sa loading, itong section modulus, this is based on the W section itself. Di ba kasi lahat ng W section natin, may kanya-kanya tayong moment of inertia, may kanya-kanya tayong section modulus. So for question B, we are asked what is the actual section modulus of the section itself. Yung una, the section modulus based on the loading. Pangalawa, what is the section modulus of the section itself? So, very important that we can distinguish both of that, no? Yeah. So, how do we solve? Do we have another equation for section modulus? Meron pa ba tayong alam? Based on the, that would be based on the void punch?
Compute po ang moment inertia po, ma'am.
Yes pa, correct. Now, di ba, ginamit din natin siya earlier. Thank you, Mr. Bares. Di ba, ginamit din natin siya before, no? M is equal to, M. Section modulus is actually equal to your I over C. Di ba? Kaya yung MC over I natin, it can also be written as M over SX. Because your SX is equal to I over C. Now, if you'll notice, I is based on the cross-section. C is also based on the cross-section. So, this equation actually is dependent on the cross-sectional property of the white punch itself. So, ito yung gagamitin natin. So, having said that, yun, tulad ng sabi ni Mr. Bares, compute muna natin yung moment of inertia. And then, since this is symmetrical, madali lang naman pag-compute ng I. Di ba, you have a lot of options. You can compute the moment of inertia of this big rectangle minus the moment of inertia of this smaller rectangle, or compute it individually, then add. So, up to you. So, madali lang. So, what I did was, I computed the moment of inertia of the big rectangle, then subtracted the moment of inertia of the smaller rectangles. Again, you will arrive to the same answer lang naman po. Ayan, solving. Now, the moment of inertia of the section modulus is 1.16 times 10 raised to 6. Raised to 9. Mm raised to the 4. Now, as for your C, this is symmetrical. So, obviously, the centroid is at the center. So, 600 divided by 2 is 300. So, that would be your C. Yun. As you can see, the section modulus of the section is smaller than the required. Anong ibig sabihin niya? Ibig sabihin po is, hindi niya kayang i-carry yung loading. Kasi ito lang yung section modulus. The requirement for the section to be able to withstand the given loading should be 5, 7, 4, 5, 9, 6, 7. Ito 3, 8, 6, 6, 6, 6, 6 lang. So yun. Now, this will answer the question C. Determine the width of the top and bottom reinforcing plates, 12 mm thick if necessary. Now, since hindi kaya nung W section alone, yung loading, actually, sa actual law, you have two options here. Pwedeng lakihan nyo yung section or magdagdag tayo ng plate to strengthen the section. So, dito sa problem na to, no, the alternative here reinforcing plate at and bottom down. No, kasi nga, kulang yung section modulus of the section. So, to strengthen the section, we're going to add a top and bottom reinforcing plate. That is 12 mm in thickness. So yun. So, if necessary, so obviously necessary siya. So, ang next na gagawin natin is compute natin yung width. So, how do we do that? So, therefore, additional plates are needed. So, anong gagawin natin? So, first thing na gawin natin is i-draw muna natin siya na meron na siyang plate. Ganito yung itsura. Yes. So, how do we compute for your P? So, actually, what you need to do here is you need to use the required section modulus kasi yun yung basis natin, di ba? Dapat yung section modulus natin is nasa 5 million something. So, yun yung dapat na magamit natin or gamitin natin for us to satisfy the need, no? So, i-equate natin yung na-compute natin na section modulus dito sa bagong section. So, in that case, we have, ilan na nga, 5,745,967. So, for the section modulus, required yung gagamitin natin, I over C. So, the only thing we can do here na mas mabilis is compute for the I. So, ang gagawin natin is we will equate the I required to the I of the new built-up section. Lagay ko na lang new. So, for the I required, since this is your section modulus required, I required, ang C naman natin is, alam natin, sorry, yung C na gagamitin na natin, since built-up section na siya, is yung, ito pala, sorry, 312. Sorry. Ito, from the top, since meron naman tayong thickness, so this is 300. This will be your I required. So, yung na-solve natin earlier, so hindi ko siya memorize. So, well, it's new meetup section. So, paano natin gagawin? Same lang, di ba? How to compute for the I. First step, locate the centroid. Obviously, they are, tapos, sorry, yung centroid nila is not along the x-axis. So, we will use transfer equation for your plate. Pero sa W section, since it's already along the x-axis, so ikakopy lang natin. So, solving it now. So, for the I of the wide flange, na-solve na natin siya kanina. Sorry. I of the wide flange, 1.16 times 10 raised to 9. Kakopy ko na lang po. 1.16 times 10 raised to 9. This is for the wide flange. Plus, again, we need to use the transfer equation for the two plates. Now, since they are identical, and then symmetrical pa, so times 2 ko na lang. This is for the plate. So, I is BH cube over 12. So, B height is 12. 12 plus area. Sorry, dito ko na. Area is base times 12 plus the D. Again, D is the distance from the original centroid to the new centroid, 306. Squared. So, times 2 siya kasi we have 2 plates. Now, if you'll notice, the only unknown in this equation is your D. Now, so, simplifying this, ang ginawa natin, we equated the requirement, so that this new built-up section will satisfy the requirement based on the loading. So, in-equate natin siya. So, simplifying this further will give us the value of your B. Tingnan natin. Yan. So, yun ginawa natin, the moment of inertia of the combined section. And then, the I based on the required section modulus. Then, equating the two. Ito yung kanina ginawa ko, I and I requirement. So, simplifying this, you will have your B. Kapag ganito yung equation, huwag kayong mag-shift solve agad-agad ang tagal niya. So, simplify nyo lang, madali lang naman yun. Diba? All you need to do is use your algebra to simplify. So, this minus this, and then simplify further. So, the value or the width of the plate is equal to 281 0.52. So, ang ginagawa natin is we are designing the beam that can withstand the given loading. Now, since hindi kaya ng W section, mag-add tayo ng plate. Now, so the width of the plate is 281.52, thickness is 12. So, yun yung magiging width. Yan. So, questions or clarification dito before tayo pumunta sa next. Sige, wala naman. Yan, that is how you compute for the width. Next naman yung length naman. 281.52. The length of the plate. Kasi, hindi ibig sabihin na you need to have a plate all throughout the length. Ang haba niya. That is 9 meters in length. Now, since nagdi-design tayo, maybe it's possible that we only need to have a plate at near the support, no? So, pwede din kasi yun, or do we need to have it all throughout the beam? So, again, since we are engineers, no, although we want our section or structure to be safe, we want it also to be economical. So, check lang natin yung, ano ba yung requirement, no, para masatisfy niya yung given loading. So, since we already have the cross-section, check naman natin what would be the ideal length of the plate so that we can carry the given loadings. And so, what would be the length of the top and then the reinforcing top and bottom reinforcing steel plates? So, first thing that you need to do, gawin nyo is visualize mo muna yung itsura ng beam. So, I think I have it here. So, drawing naman natin. Ito na siya, mag-wag ko na i-drawing. Andito naman. Ayun. So, and then, we have computed earlier din, yung maximum moment or the moment of based on the loading, that is 855 kilonewton meter. So, what you need to do is compute the moment capacity of the wide flange alone para makita natin yung difference or the needed portion, no, para ma-satisfy natin yung 855 kilonewton meter. So, I think yan. Kanina na 855 kilonewton meter. And then, next step is we solve for the moment capacity nung hindi pa natin siya ginagawang built-up section. Have it here. So, the reaction is 280. So, the moment capacity of the beam alone, no, without the plate first is 575.36. So, before we add the plate, ang kaya lang na moment ng beam is 575.36. So, therefore, no, ang actual na moment na i-carry ng beam is 855. So, what you need to do is, we will locate or we will say since dito yung portion, no? Sorry, mali lang yung figure. Ang plate po natin is nandito sa support. No? Mali lang ako sa figure. So, we don't know the length. Ito yung length. Ito yung i-compute natin. No? So, how do we solve for that length? Now, since we already know the moment capacity of the beam alone, that will be the moment, no, at this portion. This will be your 575.36. No, kasi at this portion, this is the portion where we will add the additional plate, no, so that we can strengthen the beam itself. So, what you need to do is just cut it at this portion, then draw the free body. So, ito na yung reaction natin na 280. This will be the distance x or the length of the plate. Ito na yung capacity 575.36. Na tapos, ito naman yung loading natin. That is 40. So, doing summation of moment, di ba? Mag-moment tayo at the portion where we did the cut. You can actually solve for your x. So, solving, say, summation of moment clockwise. Say natin, we have 280 times the distance x minus 40 times x over 2, so 20x squared. No, tapos minus 575.36. So this is quadratic equation, so you may, then you can now solve for the value of x. Kasi ito na lang yung ano. Huh? So there you have it. Let's solve for the value of x. Hindi ko rata na drawing FD. Di ba? And so the x is equal to 2.5. So at both ends, now the length of the plate for both ends is 2.5 meters. So you don't need to have a plate all throughout the 9 meters length. So yung required lang to strengthen your beam is 2.5 at both ends of the beam.